Right now, a heat event is building over the United States, and forecasters say it will reach the East Coast in about 10 days. We have been here before this summer, twice already. A wall of heat pressed down on cities from Washington to Boston, pushing temperatures past 100 degrees. The air felt like walking into an oven. Overnight lows refused to fall below 80. Millions of people went to sleep in heat that would have set records a generation ago. And that heat came and went and came again. But here is what makes this moment different. The thing driving all of it has not gone anywhere. A monster El Niño is growing in the Pacific Ocean. Scientists say it could become the strongest ever recorded, and that single fact is changing the weather for hundreds of millions of people right now, in ways that are going to get stranger before they get better. We're going to follow this heat, where it comes from, how it builds, what it does to a city, to a power grid, to a human body, and what the next 10 days might bring for everyone living on the East Coast. This story is happening right now, and it is bigger than most people realize. Picture the atmosphere above you as a river, a fast-moving invisible river of air called the jet stream that wraps around the whole planet at about 30,000 feet. It flows west to east, usually, and as it moves, it carries weather systems along with it. Cold fronts, storms, rain, everything slides through and keeps going. On most days, that river is why your weather changes every few days rather than sitting still for a week. But sometimes the river bends. The jet stream buckles north, like a river that hits a wide, flat valley and spreads out. When it does, something gets left behind. A big dome of high-pressure air parks over a region and refuses to move. The jet stream flows around it, not through it. Storms get shoved out of the way. Rain stops, clouds disappear, and all that sinking, spinning, compressed air heats the land beneath it like a lid sealing a pot on a stove. That lid is a heat dome. Here is what makes it so effective. Air under pressure gets hot. Every foot that air falls toward the ground, pressure squeezes it tighter. Tighter air means faster moving molecules. Faster moving molecules mean higher temperatures. The air does not need the sun to warm it. The falling and squeezing does the job on its own. By the time the air reaches the surface, it arrives already hot. Then the sun piles on. Clear skies with no clouds mean full solar heating all day, and all that energy has nowhere to go. The lid also keeps moisture out. A heat dome blocks the rain, and dry ground heats faster than wet ground. So the land under the dome gets drier and drier every day, and hotter every day, and the dome above just keeps pressing down. Meteorologists have a specific name for the most powerful version of this setup. When the jet stream bends into a shape that resembles the Greek letter omega, a ridge in the middle with troughs on both sides, they call it an omega block. The structure is so stable it can sit locked in place for weeks. This summer has already produced several of them. The weather has not been random. Something has been driving this pattern, and to understand what, you have to travel about 9,000 miles west of the East Coast to the surface of the Pacific Ocean. The Pacific Ocean holds more water than all other oceans combined, and right now a strip of that water, running east to west across the equator, is running hot. Under normal conditions, trade winds blow steadily west across the tropical Pacific, pushing warm surface water toward Asia and pulling cooler deep water up off the coast of South America. It is like a conveyor belt. The warm water piles up in the west, the cold water keeps the eastern Pacific cool, and global weather patterns march along in a fairly predictable way. Every few years, that conveyor belt slows down or reverses. The trade winds weaken. Warm water that had been shoved to the west sloshes back east. Temperatures in the central Pacific rise by a degree or two above average, and the whole global atmosphere notices. That event is El Niño, Spanish for the little boy, named by Peruvian fishermen who noticed warm water arriving off their coast around Christmas. The warming of the Pacific triggers a chain of changes around the world. Rainfall shifts, storm tracks move, heat builds in places that usually stay cooler. Scientists have tracked El Niño events going back over 100 years, and they understand its fingerprints well. What they did not expect this summer was how fast this one arrived, or how strong it has become. The ocean surface in the central Pacific climbed past the threshold for El Niño in early June, weeks ahead of schedule. By July, sea surface temperatures were already running at record levels for this point in the year, levels that, in the past only showed up months into a fully developed event. Every major forecast model pointed the same direction. Scientists at the Union of Concerned Scientists put the odds of this El Niño becoming the strongest in recorded history at roughly 9 in 10. That record would beat the 1997-98 event, the 1982-83 event, every El Niño in at least 155 years of modern observation. And it is developing right now in the ocean, with most of its strength still ahead of it. What is already happening on the East Coast may be just the early chapters of a much longer story. On July 2nd, in Washington, the temperature hit 102 degrees, a record for that date. The next day, it hit 102 again. On July 4th, Independence Day, the 250th birthday of the country, the capital reached 103, 3 consecutive days above 102. That had happened only once before in Washington's entire record-keeping history, in 1930. Philadelphia went 3 straight days above 101 degrees. That had never happened. Central Park in New York City hit 100 degrees for the first time in 14 years. Boston crept into triple digits. Newark hit 104. Atlantic City tied its all-time highest temperature ever recorded at 106 degrees. In a single stretch from June 30th to July 5th, at least 148 daily high-temperature records fell across the eastern United States. Cities from Raleigh to Halifax were marking firsts, but the number that tells the whole story is the nighttime low in Philadelphia, in Baltimore, in New York. Overnight temperatures refused to fall below 80 degrees. That detail matters more than the daytime highs because the human body needs the night. It needs the hours of lower temperature to cool down, recover, and prepare for the next day's heat. When the overnight low stays above 80, there is no recovery. Every day starts worse than the last. A body under stress from heat that never relents is a body running out of reserves. That is what makes a multi-day heat dome dangerous, in a way a single hot afternoon never is. Anyone can survive one hot day. The math starts to change on day 3, on day 4, on day 5. The body keeps fighting the heat, and it keeps losing ground. And in cities made of concrete and asphalt and brick, the heat at night is always worse than in the fields and forests outside them. A city is a heat machine. Walk out of a forest and into a city and you can feel it in minutes. The pavement is warmer, the air is thicker. On the hottest nights, the gap between the city centre and the farmland just 30 miles away can stretch to more than 20 degrees. Scientists call it the urban heat island, and it is one of the most reliable facts in all of climate science. Here is why it happens. Open land has trees. Trees shade the ground, and more importantly, they move water. Through a process called evaporation from their leaves, trees pull moisture out of the soil and release it into the air. That moisture costs energy, heat energy, which the tree pulls from the surrounding air. Trees are natural air conditioners. A forest is a giant cooling system. A city replaced all of that with stone. Concrete absorbs sunlight all day and holds it. Asphalt does the same. Dark roofs, steel, glass. These materials store heat during the day and release it slowly through the night, which is exactly why city nights stay so much warmer than country nights. There is almost no evaporation happening. The cooling system is gone. By day, a city of 1 million people runs perhaps 6 degrees hotter than the surrounding countryside. By night, that gap can flip to 20 degrees or more. And during a heat dome, when the whole region is already running 10 or 15 degrees above normal, those extra degrees in the city are not just uncomfortable. They are life-threatening for the people least able to escape them. In New York and Philadelphia and Baltimore and Washington during the July 4th heat dome, power was failing in neighborhoods. Cooling centers were packed. Emergency rooms were filling up. In New York City alone, more than 378 people showed up at emergency rooms for heat illness in a single stretch. The heat was arriving at the exact same time as the biggest outdoor celebration in 14 years. Hundreds of thousands of people on the National Mall in Washington, in the sun, with no shade, on the hottest 4th of July in the city's recorded history. The grid was straining under all of it, and it was only going to get harder from there. On July 2nd, 2026, the The largest power grid in the United States came within a few hundred megawatts of breaking its all-time record for electricity demand. The grid is called PJM. It serves 67 million people, roughly 1 in 5 Americans, across 13 states and Washington the capital. Homes, hospitals, businesses, traffic lights, water pumps, all of it runs on PJM's current. And on that Wednesday, every single air conditioner in its territory was running at the same time, all afternoon, in triple-digit heat. The forecast for peak demand that day, 166,000 megawatts. The previous all-time record set back in 2006 was 165,000 megawatts. Energy Secretary Chris Wright signed emergency orders, giving PJM the authority to do something it almost never does. Data centers, the massive server farms that run the internet, spread across Northern Virginia in the tens of thousands, were ordered to switch to their own backup generators. The government pulled them off the main grid to protect hospitals and homes. 1 megawatt powers about 800 average homes. PJM was trying to produce enough electricity for roughly 60 million average homes, simultaneously, on the hottest day the region had ever demanded. The system held, but just barely. More than 200,000 customers lost power anyway, as transformers overheated and local equipment failed neighborhood by neighborhood. Con Edison in New York was quietly reducing voltage, deliberately lowering the strength of the current flowing into homes to keep the equipment from burning out. Less voltage means air conditioners work less efficiently. On the hottest night in years, people's AC units were quietly becoming weaker. Most people had no idea it was happening. This is the hidden danger of extreme heat. The power grid runs hottest exactly when people need it most, and the system was built decades ago, designed for a different climate. Now, something new is pressing against those old design limits, and the demand is only growing, as more electric vehicles, more data centers, and more people trying to stay alive in the heat put more load on a system built for a different world. The next wave is already forming, and the grid's managers know it. On July 13th, 2026, a meteorologist at the National Weather Service office in Billings, Montana, looked at his instrument readings and did not believe them. Miles City had just recorded 115 degrees, Billings itself 111, Sheridan, Wyoming 109. 5 official climate stations within a single forecast area had all broken their all-time temperature records on the same day, simultaneously. The previous record for Miles City, set back in 2012, was 111 degrees. This new reading beat it by 4. Montana, 115 degrees. People moved to Montana to escape heat. A large portion of the population does not own air conditioning. The state's standing all-time record, set in the 1890s and again in 1937, is 117. Miles City on July 13th was 2 degrees short of the Montana state record. 2 degrees. In the state most famous for cold winters and cool summers, NASA processed the satellite imagery from that day. The darkest reds on their temperature map, the colors reserved for the most extreme readings, were not over Death Valley or the Arizona desert. They were over the northern Rockies, over Montana and Wyoming, over places where people had never needed to think about heat as a danger. The same heat dome system that had just scorched the East Coast had drifted west and intensified. At its peak, the Washington Post reported it as one of the 2 strongest heat domes on the entire planet at that moment, rivaling one sitting over northern Africa. It then began tracking east again. The question was how much of it would arrive on the East Coast when the next event was forecast for the first week of August. The heat was not finished, the summer was not finished, and forecasters were already watching the models for what was building next. The human body is a cooling machine. It has been doing this job for a very long time. Your core temperature, the temperature of your vital organs, your heart, your brain, runs at about 98.6 degrees. That narrow band is what keeps you alive. Your cells run chemical reactions that only work within a small range. Your proteins hold their shape only within that range. Go too far in either direction, and things start to fall apart in ways that cannot be reversed. When you get hot, your blood vessels widen near the skin. Blood rushes to the surface to dump heat into the surrounding air. Your sweat glands open. Sweat reaches the skin and evaporates, and evaporation pulls heat with it. A hard-working person can sweat more than a litre per hour. The body is trading fluid to stay cool. The problem arrives in two forms. The first is humidity. Sweat only cools you when it evaporates. Humid air is already saturated with water vapor. When the air is 90 degrees and 80% humid, sweat barely evaporates at all. The body keeps sweating, it keeps losing fluid, but it is not cooling down. The heat index, what the temperature actually feels like once humidity is counted, can run 15 or 20 degrees above the actual air temperature. During the July 4th heat dome, the heat index in Washington and Philadelphia topped 115 degrees. The thermometer said 103. The body did not care what the thermometer said. The second form is time. Even a healthy body starts losing the fight after enough days. The reserves run lower. The fluid balance gets harder to maintain. The heart works harder to pump blood to the surface. Organs that are already under stress from age, illness, or medication start to fail. When core temperature climbs to 104 degrees, a specific threshold is crossed. At that point, the body's proteins begin to change shape, to unfold in ways they were not built for. The brain notices first. Confusion sets in, speech becomes slurred, decisions become impossible. This is heat stroke. And once it starts, the window for survival is narrow. The only treatment is rapid cooling, ice water, cold towels, anything, before the organs shut down. In a city where the power is flickering, where the nearest air conditioning is a bus ride away, that window can close faster than anyone arrives to help. To understand what heat actually does to a community, you have to go back to July of 1995, in Chicago. The heat arrived on a Wednesday. By Thursday, the temperature in the city was 113 degrees. With humidity, it felt like 126. The heat dome held for 5 days, and by the time it broke, 739 people were dead. Most of them were old. Most of them were poor. Most of them died alone, in apartments with no air conditioning, with windows locked shut for safety in neighborhoods where crime was the constant fear. They died behind locked doors. The coroner's office ran out of space. The county brought in refrigerated meat trucks and parked them outside the morgue. No one had seen it coming. The city was not prepared. The mayor, the health commissioner, the fire department chief, 3 of the 4 key officials were on vacation during the first days of the event. The city's human services director initially described the deaths as people who had neglected themselves. 739 people. That is more than Sandy and Harvey combined, more than any hurricane to hit the United States in the preceding decade. Killed by temperature alone, in a major American city, over 5 days. The 1995 Chicago disaster changed how American cities think about heat. It forced the development of heat emergency plans, cooling center networks, wellness checks for elderly residents, and protocols that did not exist before. Chicago itself spent years building a better system. By 2012, a comparable heat event killed 22 people rather than 700. The preparation had saved hundreds of lives. But preparation requires time, it requires resources, it requires knowing that the heat is coming. What happens in the cities that are not yet prepared? What happens when the heat arrives someplace that has never had to plan for it? That question is not about history. It is about right now, and it gets harder to answer every summer. There is a neighborhood in every American city that heats up faster than the rest. It has less shade, more pavement, older buildings with smaller windows and thinner walls, fewer trees. The streets are wider, which traps more sun. The residents have less money for electricity, which means lower air conditioning use, which means less relief. In Baltimore, researchers mapped the surface temperature of the city on a hot summer day. Downtown financial districts ran several degrees cooler than neighborhoods built on former industrial land. The gap between the hottest and coolest blocks reached nearly 20 degrees on the same afternoon in the same city. 20 degrees. The difference between a heat warning and a comfortable afternoon. This pattern tracks almost precisely onto maps drawn for a different purpose 80 years ago. In the 1930s and 40s, federal housing agencies created color-coded maps of American cities. Green meant safe for investment. Red meant risky. The red areas, called redlined, were almost always neighborhoods of color, where the government blocked mortgage loans and private investment for decades. Trees were not planted there. Factories were built there. industry left behind hardscape and pollution, and almost no green space. Those same red areas on those old maps are the same neighbourhoods running the hottest temperatures on satellite images today. The thermal inequality was written into the city's physical structure 3 generations ago, and it is still there. During a heat wave, it is not an abstraction. It determines who lives and who dies. People in the hottest blocks are more likely to be older, more likely to live alone, more likely to have chronic illness, less likely to have central air conditioning, less likely to have a car to drive to a cooling centre. They are also the people most likely to have been missed by the wellness check systems designed in the years after Chicago 1995, because the systems were never fully funded and never fully reached the most isolated residents. Heat does not fall equally on a city. It follows the shape of old choices, and every degree of warming makes those old choices more consequential. A heat wave does not have to kill you to change you. Emergency rooms fill up during heat events with people who have not yet reached heat stroke, but whose bodies are already in trouble. Heat exhaustion is the step before. The heart is working too hard. The blood pressure is dropping as fluid drains away through sweat. Dizziness, nausea, cramps, weakness. The body is sending every signal it has. People driving home in the heat lose concentration. Workers making split-second decisions on job sites make errors. Athletes collapse on fields in states that have not yet passed laws, requiring them to stop practice when the heat index crosses a certain threshold. In New York City, during the July 4th heat dome, more than 378 people arrived at emergency rooms for heat illness in just a few days. The city tracked that number through a public health surveillance system, but official counts miss most of what happens. People who stay home, people who treat themselves with cold water and rest. People who make decisions that lead to accidents whose connection to heat is never recorded. Traffic fatalities go up during heat waves. Workplace accidents go up. Violent crime goes up. The mood of a city changes when the air becomes unbearable. Research has documented all of it. There is also a stranger effect that takes longer to understand. A study published in the journal Nature found that extreme heat changes how people think, measurably, for hours after they cool down. Test scores drop. Reasoning slows. The brain, like the rest of the body, does not bounce back instantly. For a 15-year-old taking a summer exam, for a nurse making medication decisions at the end of a 12-hour shift in an understaffed hospital, for a driver on a freeway in 98-degree heat without working air conditioning. Heat is not just an outdoor problem, it is a cognitive problem, an economic problem, and it is building again, right now, before the last wave has finished fading. Forecasters have a word for what they are watching on the plains right now. They call it the strongest heat dome on the planet. A new high-pressure system has been building since late July over the Rockies and Northern Plains. The Washington Post reported it as expected to rival the heat dome that drove Montana to 115 degrees earlier this month, which was, at that moment, one of the 2 most intense high-pressure systems anywhere on Earth. This one may be stronger. The centre of this dome is parking over the desert southwest and the northern Rockies. Temperatures there are expected to push toward 115 degrees in some spots. Records set just weeks ago are in danger of falling again. The weather pattern producing this system is what forecasters call an omega block, the same locked, stable structure that drove the July 4th event, and one of the defining features of an omega block is that it is slow to change. Private weather forecasters issued warnings in the 3rd week of July that the East Coast should prepare for a new heat event around the 5th through 7th of August. That is roughly 10 days from now. The forecast is not yet certain. 10-day predictions carry real uncertainty, but the models that have been right all summer are pointing the same direction. The current pattern is giving the East Coast a brief window. Rain, clouds, temperatures in the 70s. After weeks of record-breaking heat, the weather feels almost cold by comparison. That window will close. The question is how quickly and how hard the next wave lands, and the system sitting over the Pacific, the one driving the entire pattern, is still growing stronger. In the summer of 2021, a heat dome landed on the Pacific Northwest. Oregon, Washington, British Columbia. This was a region that had never prepared for heat. The city of Portland, Oregon, averaged about 82 degrees in July. On June 28th, the temperature reached 116, a city without central air conditioning, with minimal shade, with concrete absorbing heat and releasing it through the night. The village of Lytton, British Columbia, a small town in a river valley, reached 121 degrees. That was the highest temperature ever reliably recorded in Canada. The next day, Lytton burned. A wildfire started outside town and moved fast in the dry heat, and within minutes the village was gone, 90% of the structures destroyed. Climate scientists analysed the Pacific Northwest event later and published their findings. Their conclusion: an event like that, producing temperatures that far above historical norms, was virtually impossible without human-caused climate change. The same researchers estimated that what was once a 1-in-1,000-year event, something that should happen roughly once every 10 centuries, has now become a 1-in-40 or 1-in-60-year event. The probability shifted by more than an order of magnitude. The East Coast in 2026 is not the Pacific Northwest in 2021. These cities have more experience with heat, they have cooling centres, they have protocols, but the underlying dynamic is the same. Climate change raises the floor. Every heat event starts from a higher baseline. The jet stream is warmer, the oceans are warmer, the land is drier. Events that used to be extreme are now common. Events that used to be impossible are now just rare. Philadelphia went 3 straight days above 101 degrees for the first time in its history this summer. Washington had 3 consecutive days above 102, something that had only happened once before, 96 years ago. These are not random flukes. They are the new shape of summer, and summer has more weeks left. The sweat on your skin is not free. Your body makes it from the water you drink, and it costs electrolytes, sodium, potassium, the minerals that make nerve cells fire and muscles contract. Lose too much of either, and the body starts to malfunction in ways that feel slow at first, and then very fast. Most people in a heat wave do not drink enough water. They know they should, they just do not. Thirst is a late signal. By the time you feel thirsty, you are already behind. A person sitting in a 95-degree room without air conditioning can lose a litre of fluid through sweat and breathing without ever standing up. Outside, walking, working, that number climbs fast. Older adults feel thirst less reliably. Their kidneys hold fluid less efficiently. Their skin releases heat less effectively. Biologically, the thermoregulation system that keeps the body cool runs more slowly and less precisely as people age. Add common medications, blood pressure pills, diuretics, antihistamines, antidepressants, and many of those biological cooling systems are partially blocked. The same pill that keeps a 70-year-old's heart stable may also impair the sweating response that keeps her alive in a heat wave. This is why the deaths in Chicago in 1995 were almost entirely elderly. This is why the deaths in New Jersey during the July 4th wave followed the same pattern. The coroner's reports from heat disasters read almost identically across decades and cities. Elderly, living alone, no air conditioning, no one checking on them. Found days later. The intervention that saves the most lives in a heat wave is also the simplest. Another human being. A knock on a door, a phone call, a neighbour who notices the blinds have not moved in 2 days. In Chicago, the blocks where people knew their neighbours had far lower death rates than the blocks where residents had never spoken. Social connection is a heat survival technology, and it costs nothing. But it requires the kind of community that extreme heat, like extreme anything, tends to erode over time. The jet stream is not what it used to be. For most of human history, the jet stream circled the planet in a relatively tight, fast band. It separated the cold Arctic air from the warmer air to the south, and it kept weather systems moving. But over the last few decades, the Arctic has been warming roughly 4 times faster than the rest of the planet. That temperature difference, the gap between Arctic cold and mid-latitude warmth, is what drives the jet stream. Narrow the gap, and the river of air slows down. When it slows down, it wobbles. The loops get deeper, the patterns get more extreme. A heat dome that would once have stayed put for 3 days can now sit for a week. A drought that would have lasted a month can last a season. Flooding that arrives in concentrated bursts because the jet stream sent a storm system the same direction 3 times in a row. Scientists call this atmospheric blocking, and the evidence that it is becoming more common and more persistent is growing. This summer has demonstrated that pattern in real time. Heat dome after heat dome, each one sitting and baking before slowly dissolving and allowing the next to form. The system is not cycling through bad weather and good weather the way it used to. It is holding patterns, repeating them. The East Coast had weeks of heat, a brief pause, and is about to enter another round. The West went from its own pause into record-breaking heat in July. The pattern reset fast, and it looks ready to reset again. Researchers at major climate institutes have run the calculations. The kind of summer that used to happen once every 50 years in the northeast United States is now expected roughly every 5 to 10 years. The kind that used to happen once every 20 years is closer to once every 5, and because El Niño is still growing, still pushing more heat into the atmosphere, still disrupting the same jet stream, the summer of 2026 has at least several more weeks of uncertainty ahead. The August wave is building, the models are watching, and the jet stream will do what it does, which is hold the pattern a little longer than anyone quite expects. There is a number that keeps appearing in the climate science literature on heat: wet bulb temperature, wet bulb 35. Wet bulb temperature is different from the regular thermometer reading you check on your phone. It measures how hot the air feels when evaporation is factored in, essentially the lowest temperature the human body can theoretically cool itself to through sweating. When wet bulb temperature reaches 35 degrees Celsius, which is 95 degrees Fahrenheit, healthy young adults sitting in the shade cannot cool themselves. Full stop. No amount of sweating helps. The physics of evaporation simply stop working. For decades, scientists thought that wet bulb 35 was a theoretical limit that humans would never actually encounter because it had essentially never been recorded. Then, around 2020, researchers began finding it in places like the Persian Gulf and parts of Pakistan. Brief spikes, measured in hours, still survivable if you moved quickly to a cool space, but real. The east coast of the United States is not currently approaching wet bulb 35. The July 4th wave, with its heat index readings above 115 degrees in some cities, came nowhere near that absolute limit. The actual danger on the east coast is a lower threshold, around wet bulb 28 to 30 degrees, at which older adults and people with health conditions can no longer thermoregulate safely. But the trajectory matters. The Persian Gulf recorded wet bulb 35 in 2020. Scientists had calculated it would not appear there until 2050 or later. It arrived 30 years ahead of schedule. The East Coast's equivalent thresholds, the temperatures at which the region's specific population, with its specific health conditions and demographics, starts dying in large numbers, are shifting in the same direction, not as fast, but the direction is set, and El Niño is pushing in that direction right now. The forecasts for August 5th through 7th carry a number, mid to upper 90s. That is not as severe as July 4th, when triple-digit heat baked Washington for 3 straight days, but mid-90s in early August, arriving on a population that just went through one of the hottest Julys in recorded history, is a different thing than mid-90s on a rested, prepared population in June. Heat accumulates in the body over a summer. Researchers call it heat stress. The body's regulatory systems work well once, reasonably well twice, and begin to show cracks after repeated exposure without full recovery. Older residents who lived through the July waves without any serious symptoms may be more vulnerable in August, simply because their systems have been working harder for longer. The reserves they had in June are thinner now. The ground is also drier. The soil holds heat differently when it has been baked for weeks. City infrastructure, water pipes, transformers, road surfaces, has been under thermal stress. Pavement that was already hot in July does not cool fully between events. The starting temperature for August is higher than the starting temperature for June, in ways that compound the human body's condition. Private forecaster Commodity, WX Group, flagged the early August timing for the East Coast on July 24th. Bloomberg temperature data pointed to climbing temperatures beginning in the final days of July, peaking in the first week of August. The National Weather Service is watching the same signals. 10 days is not a long lead time, but it is enough. It is enough to check on elderly neighbours, to find the closest cooling centre, to make sure medications are not making anyone more vulnerable, to stock water before the stores run out. The first heat dome of the summer arrived while many people were caught off guard. The third one is approaching with 10 days of warning. What happens next depends on what people do with those 10 days. The smoke arrived over New York City on July 16th without warning. Residents woke to an orange haze hanging over Manhattan. The Statue of Liberty disappeared behind a curtain of brown. The skyline, visible from Jersey City every clear morning, was gone. It smelled like a campfire, one so large no one could locate its source. The source was Ontario, Canada, roughly 500 miles to the north, where nearly 900 wildfires were burning simultaneously. Heat does not just kill directly, it dries the land. Dry land burns, and when it burns at scale, it sends smoke across state lines, across national borders, across 1,000 miles of atmosphere, and deposits it on cities that had nothing to do with the ignition. On that single day in July, 50 official air quality monitors across 5 states recorded readings in the hazardous range, the level at which the air is dangerous for every person, healthy or not, young or old. Yale climate scientists called it the most extreme wildfire smoke event in the region's history, larger than the June 2023 event that had previously held that record, when only 3 monitors in Pennsylvania hit hazardous readings. In July 2026, 50 monitors hit hazardous. In one afternoon, Detroit became the most polluted major city on the planet. Heat and smoke together create a compounded crisis. Every person who goes outside risks both heat illness and lung damage at the same time. Cooling centres, the places where the most vulnerable people are supposed to go to escape the heat, are often poorly ventilated, and filling them with people in smoky conditions creates its own problems. Masks help with smoke. Masks make it harder to cool down. The fires in Canada were made 5 times more likely by climate change, according to scientists who analysed the conditions. Meaning, a world without a century of warming would produce this kind of smoke event far more rarely. The world with warming is producing it with increasing frequency, and the heat dome that dried the land and primed it for burning was the same system that had just scorched the East Coast weeks earlier. The events are not separate. They are the same event wearing different faces. A rail line is designed for a specific temperature range. The steel expands as it heats and contracts as it cools, and engineers account for that when they lay the track. They leave small gaps. They anchor the rail at specific intervals. The whole system is calibrated for the climate the engineers expected when they built it. When the air temperature hits 100 degrees, the surface of a rail in direct sun can reach 160 degrees. At that temperature, steel that was designed for the normal range starts to push outward. The anchors fight back. The rail has nowhere to go, so it buckles sideways, what engineers call a sun kink. A train hitting a sun kink at speed derails. That is why Amtrak slows its trains during heat waves. It is why Washington's metro system caps speeds at 35 miles per hour when rail temperature exceeds 135 degrees. Roads face the same problem. Concrete is poured in slabs with gaps between them, expansion joints, designed to give the material room to grow. When heat pushes beyond the design range, the concrete fills those gaps and keeps pressing. The pavement buckles upward. On highways in Wisconsin and Georgia and Illinois during the July heat event, drivers encountered sudden concrete humps rising inches above the road surface. The Illinois Department of Transportation warned drivers to stay alert for pavement failures as temperatures climbed. Bridges are perhaps the most elegant victims. The 3rd Avenue Bridge in New York, a swing bridge that pivots open for ship traffic on the Harlem River, got stuck during the 2024 heat wave when its metal expanded and the pieces could no longer slide back together. Traffic stopped. Boats stopped. The fix required waiting for the air to cool. All of this infrastructure was built for a climate that is now changing. The repair costs are enormous. The disruptions compound during the same days when heat is already straining the system. A road that buckles during a heat dome slows the ambulances, the delivery trucks, the buses carrying people to cooling centres. Infrastructure stress and public health stress arrive at the same time, from the same source. In August of 2003, Europe baked under a heatwave that lasted 2 weeks. Temperatures in France reached over 104 degrees. The country lost around 14,800 people in a few weeks, most of them elderly, most of them dying alone in apartments without air conditioning. Paris alone lost more than 2,000. It was the worst natural disaster in France in more than 50 years. The French government was devastated. The country reorganised its entire emergency response system after that event. It created a national heat alert network, mandatory cooling measures for care homes, and systematic welfare checks on elderly residents during heat warnings. It invested in shade, public fountains and air-conditioned spaces open to anyone, Then came 2022, another brutal European summer, roughly 20,000 excess deaths across the continent. France's system had saved many lives, but the heat was getting hotter and the losses were not zero. Then 2023, 47,000 excess deaths across Europe for the summer, including about 9,500 in France. In Spain, about 7,500. In Italy, around 10,000. Then 2024. The wave passed through again. Now, 2026. The hottest June ever recorded in Western Europe. Germany hit a new national record of over 106 degrees near the border with France. France had its hottest June day ever at 110. Thousands of excess deaths, most of them in France, Spain and Belgium. The World Health Organization confirmed more than 1,300 excess deaths in just the first week. Officials cautioned that the real number would be higher once all the data arrived. Across the continent, hospitals were struggling. German hospitals activated disaster protocols. An emergency room in Bonn reported that its basement ward had climbed to over 82 degrees Fahrenheit. At least one London hospital lost its air conditioning on a geriatric ward. France was preparing for the second wave before the first had finished. This is not what a decade ago looked like. The trend is not subtle, it is visible in every year's data, and the Atlantic Ocean between Europe and the American East Coast does not make the East Coast immune. The people dying in heat waves are not dying from heat alone. They're dying from heat combined with everything else already wrong. A person managing high blood pressure takes a diuretic. The diuretic makes the kidneys flush extra fluid. In normal conditions, the person stays hydrated, and the medication works as intended. In a heat wave, the body's already losing fluid through sweat faster than it can be replaced. The diuretic accelerates the process. Dehydration sets in faster and more severely than it would in a person not taking that medication. The heart, now working harder to cool the body, is also working against the additional strain of the low blood volume. This is why so many heat deaths occur in people who, on paper, were being well managed for their conditions. The conditions were managed for a different world. Beta blockers, common heart medications, blunt the body's ability to respond to stress. They slow the heart rate. During heat, when the heart needs to speed up to push blood to the skin for cooling, a beta blocker works against that. Antidepressants in a class called tricyclics reduce sweating. Anticholinergic medications, used for bladder problems, allergies, sleep, impair the body's entire heat response system. Some antipsychotic medications raise the body's internal temperature slightly on their own. Millions of Americans over 65 take multiple medications from these categories at once. Their doctors know this. The medications are correct. The problem is not the prescriptions. The problem is a summer that now regularly exceeds what the human body was designed to handle at the doses those prescriptions were calculated for. Every heat wave turns a well-managed condition into a crisis. Doctors and pharmacists in Philadelphia and Baltimore and Washington, during the July 4th wave, were advising patients to check with their doctors about their heat risk from specific medications, but only if those patients were connected to healthcare providers who communicated during emergencies, which many elderly patients who live alone are not. The disconnect between the medical system and the heat emergency is one of the gaps that kills people in the hours between when the heat peaks and when anyone realizes something is wrong. Here is something that sounds technical but carries the weight of a warning. The ocean is running out of room to absorb heat. For decades, the ocean has functioned as the planet's buffer. About 90% of the excess heat trapped by greenhouse gases in the atmosphere has been absorbed by seawater rather than heating the air. This is why global surface temperatures have not risen even faster than they have. The ocean has been absorbing the overflow, but the ocean is getting warmer. The surface is warmer, the deep layers are warmer. Marine heat waves, patches of ocean running far above normal temperature, now cover roughly 40% of the world's ocean surface at any given time. The Atlantic Ocean off the East Coast has been running at record temperatures for much of the past 2 years. The Gulf of Mexico is hotter than it has been in modern observation. A hotter ocean changes two things. First, it has less capacity to absorb more heat. The buffer is weakening. Second, a warmer ocean off the coast of a major population centre adds moisture to the air. More moisture means more humidity. More humidity means heat feels worse, feels more dangerous, and more efficiently prevents the body from cooling through sweat. The heat index readings in Washington and Philadelphia during the July 4th dome, exceeding 115 degrees in some spots, were partly a product of the ocean. The moisture loading the air came from water that was running abnormally warm off the Atlantic coast. The Gulf of Mexico was contributing the same way to heat events across the southeast. As the ocean continues to warm, the moisture it injects into East Coast air masses during summer heat events will increase. The heat index will continue to climb faster than the air temperature. The danger threshold, the point at which a given number of people begin dying, will arrive at lower and lower actual temperatures, because the humidity will carry more and more of the load. The ocean is changing the math on what a hot day means. The workers on a construction site in Philadelphia on July 3, 2026, had no federal requirement protecting them from the heat. They had water. Their employer had provided it. They had shade breaks if they asked. But there was no federal standard mandating shade, mandating rest intervals at specific temperatures, mandating a cutoff point at which outdoor work must stop. OSHA had been working on a federal heat standard for years. Public hearings had concluded in the summer of 2025. The rule was not yet final in the summer of 2026. And in April of that year, the existing emphasis program, the limited set of inspection priorities for heat-related hazards, expired without renewal. The gap in protection is not an accident of indifference. It is a gap in time. The standard is proposed. The hearings have happened. The process is moving. But the summer arrives faster than rulemaking does. And every summer in the gap is a summer where the 32 million Americans who work outdoors for a living go to their jobs without a legal floor under their safety. Farm workers, construction workers, landscapers, road crews, utility workers, delivery drivers, the people who keep the physical infrastructure of the country running, are the people who have the least ability to pause work because the temperature crossed a number on a thermometer. California passed its own heat standard for outdoor workers years ago and found it reduced heat-related deaths in covered industries by roughly half compared to neighbouring states over the same period. The same summer that other states saw heat deaths rise by over 100%, California's rose by far less. This is not a mystery about what works. The mystery is why it takes so long to make the protection universal. While the process continues, the heat dome is not waiting. The August wave is building. The workers will report on Monday morning, and the thermometer does not care about the rulemaking calendar. Agriculture runs on water and temperature. Not the temperature outside on the hottest day, but the average temperature across a growing season. The overnight low, the number of days above a critical threshold, the timing of frost and melt. El Niño changes all of those numbers simultaneously, and it changes them differently in different parts of the world. The current event is already tilting harvests on 5 continents. In Southeast Asia, lower rainfall is expected to stress rice crops. In Australia, the combination of heat and dryness that El Niño brings risks reducing wheat yields dramatically. In the 2002 El Niño year, Australian wheat output dropped by more than half from one season to the next. In sub-Saharan Africa, the changed rainfall patterns carry the risk of crop failure in regions that already have almost no buffer against food shortages. The 4 crops that matter most to global food security are wheat, rice, corn, and soybeans. Those 4 account for more than 60% of all calories consumed globally. A strong El Niño does not necessarily collapse global production of all 4 simultaneously, but it does not have to collapse all 4 to cause serious harm. If 2 of them face large shortfalls in the same season, global food prices spike. The populations least able to absorb price spikes, in the Middle East, in sub-Saharan Africa, in parts of South Asia, face food insecurity. That insecurity does not stay contained. It moves. The particular danger of this El Niño is that it is arriving at a moment when global food prices are already elevated from the previous 3 years of supply chain disruption and conflict. There is less buffer in the system. A shortfall that would have been absorbed in 2015, when stockpiles were high, lands differently in 2026 when they are not. The farmers know this. The commodity markets know this. The governments that import food know this. The East Coast is not a farming region in the same sense as the plains, but every city on the East Coast buys food grown elsewhere, transported by systems that are also under heat stress. The heat dome that breaks a road in Illinois, is the same system that disrupts a trucking route that carries food. The connections are not visible from a city street, but they are there. There is a thought experiment climate scientists use to talk about attribution. They ask, could this specific event have happened without human-caused climate change? For the July 4th heat dome on the East Coast, the answer comes from research published within days of the event. Scientists at major climate institutes ran the models with and without the accumulated warming of the last century. Their finding: the heat wave was made at least 3 times more likely by climate change. Some studies put it higher, 10 times, for certain temperature thresholds on certain days. This is what attribution science does. It does not say climate change caused the event. It says climate change loaded the dice, the way a casino sets the odds. A casino does not make you lose on every hand. It just makes losing more likely over time. Climate change is doing the same thing with heat events. Events that were once genuinely rare are becoming common. Events that were once common are becoming routine. And events that were once considered impossible are starting to occur. The Pacific Northwest Dome in 2021 was analysed the same way. The conclusion: virtually impossible without climate change. An event that should have a 1 in 1,000 year chance of occurring in the historical climate record had happened. The dice were loaded so heavily that it arrived 96 years before the models expected it. The pattern holds across every major recent event: the European heat waves, the Australian fires of 2019 and 20, the flooding in Pakistan, the drought in the American Southwest. In each case, climate scientists find the same fingerprint: an event made more frequent, more intense, or longer lasting by accumulated warming. And in each case, the El Niño sitting in the Pacific right now adds its own layer on top. James Hansen, the Columbia University scientist who warned Congress about climate change in 1988, published in June 2026 that 2026 is on track to become the hottest year in recorded human history, with 2027 likely to be even hotter as El Niño peaks. Carbon Brief, analysing data from 5 research groups, put 2026 as likely the second warmest on record. Either way, the last 4 years will have been 4 of the 5 hottest in the history of human measurement. The city has a plan. Washington has a heat emergency protocol, Baltimore has one, Philadelphia has one, New York has one. Every major city on the East Coast has a playbook that was developed or substantially upgraded in the years after Chicago 1995. The playbook specifies when to open cooling centres, which populations to target with wellness calls, how to coordinate across city agencies, when to declare a heat emergency that unlocks emergency resources. During the July 4th heat dome, those plans activated. Cooling centres opened across the region, many of them in libraries, recreation centres, and community facilities. New York City activated mobile cooling units and sent them into neighbourhoods. In Philadelphia, the city declared a heat health emergency before temperatures peaked. Baltimore opened public pools on extended hours. Washington's transit system painted more than 6,000 feet of track with reflective white paint to keep metal temperatures lower. These measures save lives. There is evidence on that. Chicago went from 739 deaths in 1995 to 22 deaths in 2012 under a comparable heat event, largely because of the emergency infrastructure it built in the years between. The preparedness gap between 1995 and today is real, and it matters. But preparedness has limits. Cooling centres require people to get to them. Transportation breaks down in heat. Older adults who cannot drive or walk long distances in triple-digit temperatures may not be able to use a cooling centre 3 miles away. Wellness calls require a list of who to call, which requires knowing who lives alone and is vulnerable, which requires data that many cities do not have and cannot legally require. And every measure that requires someone to ask for help fails the people who do not know to ask, or who are afraid to, or who simply have no one to tell them what is available. The August wave will test the plan again. 10 days is enough time to locate the nearest cooling centre, to check on elderly neighbours, to make sure there is enough water in the house, and to understand that the system, as good as it has gotten, still needs human beings helping each other to work as well as it can. Here is a number worth sitting with: 13. 2026 is projected to be the 13th consecutive year in which global surface temperatures exceeded 1 degree Celsius above the pre-industrial baseline, the temperature of the world before humans began burning fossil fuels at scale. 13 consecutive years. A child born in 2013 has never experienced a year of global average temperature within the normal range that existed for most of human civilization. A high school student today, at the age this documentary is written for, has never lived in a world running at the temperatures their grandparents grew up with. This matters because climate has a long memory. The decisions that produced this warming were made over decades. The heat that the atmosphere holds today came from emissions that began building in the 1950s and has been accumulating since. The lag between emission and effect can be measured in years, in decades, in the difference between the warming that has already happened and the additional warming already locked in by gases already in the atmosphere. Scientists call that locked-in warming committed warming. Even if every fossil fuel source on Earth stopped burning today, a scenario that will not happen, the planet would continue warming for years, because the energy imbalance between what comes in from the sun and what the atmosphere now allows to escape is already set. The ocean, as it absorbs heat, releases it slowly. The feedback loop's already running, ice melting, dark ocean absorbing more sunlight, permafrost thawing, continue on their own momentum. The East Coast heat events of summer 2026 are not a temporary aberration in a stable system. The system has shifted. What is happening now is the new baseline, and the baseline is still rising. The summers ahead will almost certainly be hotter than this one. What feels extreme in 2026 will feel ordinary in 2036. The question is, what gets built between now and then to protect the people living through the transition? The Atlantic hurricane season has been quiet this summer, and there is a reason. El Niño suppresses Atlantic hurricanes. The same warming of the Pacific that is loading the atmosphere with heat also changes the wind patterns over the Atlantic Ocean in a way that makes it harder for tropical storms to organize. High wind shear, fast-moving air at different altitudes, tears apart the circular structure a hurricane needs to build. This summer has produced only one named Atlantic storm so far, and it was weak. Forecasters at Colorado State University revised their seasonal outlook downward after El Niño's strength became clear. The irony is almost painful. The same phenomenon driving the worst heat events in East Coast history is simultaneously suppressing the storm risk that the East Coast normally fears most in summer and fall. The reprieve from hurricanes is real. The reduced Atlantic activity is real. But it does not mean the East Coast is protected from severe weather. As the heat dome breaks, and it will break, because they always do, the energy stored in the hot, humid air does not simply disappear. It converts. Heat energy becomes storm energy. The thunderstorm outbreak that ended the July 4th heat dome produced over 540 damaging wind reports in a single day across the central and eastern United States. More than 1.3 million people lost power in the storms that finally fractured the dome. 4 people died in those storms. The storms that break heat domes can be violent. Flash flooding, dangerous lightning, damaging straight-line winds, tornadoes. When the atmospheric energy that has been compressed and baked under a high-pressure lid finally finds an exit, the release can be fast and severe. Forecasters watch the edges of heat domes carefully for exactly this reason. The break is not always gentle. The August dome, when it finally moves, will carry with it weeks of accumulated energy. The storms that follow it will arrive somewhere. The summer of 2026 is not an isolated chapter. Every summer before it has been part of the sequence. 2003, Europe loses 14,800 people in France alone. 2012, the United States has its hottest year on record at that point, and a devastating drought hammers the Corn Belt. 2021, the Pacific Northwest reaches temperatures that should have been impossible, and 900 people die in a week in British Columbia. 2023, Phoenix goes 31 consecutive days above 110 degrees. 2024, the hottest year in recorded human history up to that point, with Europe losing over 62,000 people in the summer heat. And now this one. Each summer has its own specific character, its own records, its own geography. But the sequence has a shape. The baseline rises. The records that seemed impossible in one decade become routine in the next. The events that shocked the world get replaced by worse ones. This is the thing that is hardest to hold in the mind, not any individual event, the trend, the direction, the pace at which the world that any living person grew up in is becoming something different. The number that says 2026 is the 13th consecutive year of global temperature above 1 degree. Above pre-industrial average is not just a data point, it is a clock. It marks how long this has been happening, and it does not show signs of stopping. The El Niño growing in the Pacific will peak later this year and into 2027. Its peak will push global temperatures to levels that, absent human-caused warming, would have required the entire rest of the 21st century to reach naturally. The heat it adds is temporary. El Niño fades, La Niña follows, temperatures cool slightly, but they cool to a new, higher baseline. The floor rises, and then the next El Niño adds to the higher floor. The staircase goes up. Every step is warmer than the last. The solutions exist. That is the part that makes this harder, not easier. Green roofs, building rooftops covered with soil and plants, reduce the surface temperature of a city block by 20 to 30 degrees on hot days, compared to standard dark roofs. The plants absorb water, release it through evaporation, and cool the air the way a forest does. The technology is not new. It is not experimental. Cities in Germany and Singapore and Chicago have been building them for decades. White and reflective roofs do something different. They bounce sunlight back into the atmosphere rather than absorbing it. The difference between a dark roof and a white roof on a hot summer day can exceed 50 degrees on the surface. That difference ripples into the building below, into the air above, into the thermal conditions for the block. Trees, street trees, park trees, trees planted along every sidewalk and vacant lot, cool the air by 10 degrees in their immediate vicinity. They shade pavement that would otherwise absorb and hold heat. They move moisture. A city with mature tree canopy covering 30% of its surface behaves differently, thermally, than a city at 10% coverage. The difference can be measured in lives during a heat dome. These interventions cost money to build and take years to mature. A tree planted today will reach its full cooling potential in 15 years. The time to plant it was 15 years ago. The second best time is now. Several East Coast cities have tree equity programs that specifically target the hottest, most historically neglected neighborhoods for new plantings. Researchers tracking those programs are finding temperature reductions already, even in young canopies. The thermal gap between the hottest and coolest blocks in a city narrows as the trees grow. What they cannot do is undo what has already happened in the atmosphere. The warming locked in by past emissions will continue. The solutions reduce how much each degree of warming costs in human lives. They do not stop the warming itself. Both things are true at once. The solutions matter enormously, and they are not enough alone. In a hospital emergency room in Philadelphia during the July 4th heatwave, a 67-year-old woman was brought in by her neighbour. The neighbour had knocked on her door because she had not seen her in 2 days. The woman was disoriented, her skin hot and dry, the classic signs of heat stroke. Her core temperature was 105 degrees when she arrived. The neighbour had knocked because she was paying attention. This is the variable that does not fit neatly into a government plan or a technical intervention. Paying attention to the person next to you. The heat event planning systems, the cooling centres, the wellness call lists, all of them require a human being at the end who notices something, who picks up the phone, who knocks on the door. The people who die in heat waves almost always die alone. The people who survive because of someone else's intervention are survived because someone was watching. Researchers studying the Chicago 1995 disaster found something striking when they compared the death rates of different neighborhoods. Some neighborhoods lost far more people than others that should have had similar vulnerability based on age, income, and lack of air conditioning. The difference was social connection. In the neighborhoods where people knew their neighbors, where there were community organizations, where there were businesses and churches and places where people gathered and noticed each other, far fewer people died. In the neighborhoods that were fragmented, economically hollowed out, where residents did not know each other's names, the death toll was higher. Heat amplifies the social conditions that already exist. A community with strong bonds survives better. A community with weak bonds loses more people. This is not a reason to abandon technical solutions. It is a reason to understand that technical solutions have a flaw. They can only reach the people who are connected enough to receive them. The heat is coming again in 10 days. It will not be as severe as July 4th, but it will not be gentle. And somewhere on the East Coast, in some apartment in some August week, a door that needs to be knocked on will not be knocked on unless someone decides to do it. That decision costs nothing. It requires only the kind of attention that the heat itself, ironically, tries to bake out of a city. It is the simplest and most powerful intervention available, and it has no expiration date. What does the East Coast look like at the end of this summer? The heat record for Washington's Independence Day has been reset. Philadelphia's 3-day triple-digit record has been broken for the first time in history. The largest grid in the United States came within a breath of its all-time electricity demand. More than 44 people died in the heat in the mid-Atlantic region alone. Canadian wildfire smoke turned the New York City skyline orange and left 50 air quality monitors reading hazardous in a single day. Montana hit 115 degrees, and private forecasters are already watching the models for the wave building in the first week of August. This is what the new normal looks like while it's arriving. Familiar in shape, summer, heat, sweat, the long light afternoons, but different in degree. The numbers that seemed extreme 2 years ago are now the mid-range. The numbers that seemed impossible last year are now the new records to beat. The El Niño is still growing. The peak of the current event is likely 4 to 6 months away, in late 2026 or early 2027. The heat it adds to the atmosphere this summer is a preview. The full peak will arrive in the Northern Hemisphere winter. The downstream effects on rainfall, on agricultural yields, on storm tracks across the Pacific are still unfolding. The forecasters who have been right all summer are watching those effects with the same intensity they brought to watching the heat domes. The 10 days between now and the August wave are a gap in the weather but not a gap in the trend. The system has not reset. The ocean is still warm. The El Niño is still building. The jet stream is still wobbling in the ways it wobbles when the Arctic warms faster than the rest of the planet. The atmospheric pressure maps that drove June, that drove July, that are driving the current quiet, they are all drawn from the same altered world. August 5th is 10 days away. The cooling centres will open, the wellness calls will go out, the power companies will watch their load forecasts, the emergency rooms will stock extra cooling equipment. Everything that was learned from July will be applied to August, and somewhere in that application, the knock on the door that someone decides to make, or not make, will carry more weight than any technology or protocol, because the heat finds the cracks between systems, and the only thing that seals those cracks is people looking out for each other. Here is what you are watching happen in real time this summer. The planet's climate, the system that sets the rules for what weather is normal, what is rare and what is impossible, is shifting under our feet. The shift is not uniform. It does not hit every place equally. It does not strike every week. There are cool days. There are cloudy mornings. There are brief pauses, like the one the East Coast is enjoying right now, with temperatures in the 70s and the kind of air that feels like something from a different decade. But the average keeps rising. The extremes keep expanding. The records keep falling, and the events that once belonged in the category of once in a generation are appearing with the regularity of something that happens every few years. The human mind is built to normalize what it experiences regularly. The heat that would have seemed catastrophic in 2010 feels alarming, but not shocking in 2026. And that normalization is itself a risk. The risk that each new extreme gets absorbed as the new floor, that the urgency fades because the crisis is continuous rather than sudden. The East Coast will survive the August wave. The systems built after Chicago, after the European disasters, after the Pacific Northwest event, those systems are better than what existed before. People will be protected who would not have been. Some deaths will be prevented. The infrastructure will strain but largely hold. The cooling centres will fill and serve their function, and then September will arrive, and the summer will pass into memory, becoming the summer of 2026, the one where Washington had its hottest 4th of July ever, and New York went dark with Canadian smoke, and Montana hit 115. In a few years, it may be surpassed by another summer, the way every recent year has eventually been surpassed. The story of the East Coast and the heat is not finished in August. The El Niño still has its full force ahead of it. The baseline keeps rising. The window to shape what comes next is still open. And that window, unlike the ones people were closing during the July 4th heat dome to keep the air conditioning in, is one that no amount of warmth can permanently seal.